Hello, and in this video we're going to be looking at an introduction to what a sequence is. Now, a sequence is a list of numbers that's a function where the domain values are positive integers. So these numbers that we input into the domain are going to start with 1, 2, 3, 4, 5. We won't have any negative numbers. We won't have any partial values here. There won't be any 1.5s in the domain. Each domain value is going to be a positive integer. And the output is going to be some value. Now the output is our sequence of numbers. So when we see a sequence of numbers, we just see the outputs. We don't actually see the input numbers. So in the notation for a sequence, n is the term number. This is the term number. This is the term number. So this is the first term, second term, third term. So this will be the first term. Second term. This will be the fifth term of the sequence. A sub n is the notation that we use for the term values. So if we say a sub 1 is going to be the first term. So a sub 1 represents the first term, a sub 2 represents the second term, a sub n represents the nth term. So it's a formula that we use for the nth term of the sequence. Now a sequence can have a pattern, so that most of them have some kind of pattern, so we can make some kind of prediction of what happens in the future. So that is what a sequence is, and some of the notation that you're going to be dealing with. The nth term and the term number. So a sub 1, a sub 2. Alright, the other things you need to know about a sequence is you're going to be asked to find the first 4 terms of a sequence. Now this sequence up here has some kind of rule that we write. So in this case, looking at this problem here, we have a sub n is our rule here for that thing, and then it's going to have some kind of rule up here relating the n values here to the term values. Okay, that's what we're going to be doing later on in the video. We're going to be finding those nth term formulas. First, we're just going to look at finding the terms from a rule. So this is our rule, a sub n. This is our set notation rule. It's a set of all values. This is the set notation for the rule. So that means that if we wanted to put a sub 1 in there, then what we would do is we do 4 times 1 minus 1 here. We'd put 1 in for n. So a sub 1 is 3. So my first term on this sequence is 3. That's the first term. The second term, that's a sub 2, is going to be 4 times 2 minus 1, which is 7. That's going to be my second term. A sub 3 would be 4 times 3 minus 1, which is 11. That's my third term. And a sub 4, which is my fourth term, is 4 times 4 minus 1, which is going to be 15. That's my fourth term. So we're evaluating this by plugging in the values 1 through 4 for n's for finding the terms themselves. So if we were to write this out as a sequence, we'd write 3, 7, 11, 15, and then we'd continue on in that sequence. So this would be a sub n. Okay, that would be my sequence there. So on this one here we have a rule. Now in this rule, this -1 in the parentheses, it's going to cause the problem to alternate in sign, because every time this is raised to a power, it's either going to be a +1 or a -1, depending on whether the power is even or odd. So we're just going to evaluate as we go. So we're going to have -1 here, for the first term, not a sub n. For the first term, n is 1, so we're going to have 2 up here as a power, 1 plus 1, times 2 to the first power, which is going to be, this is going to be +1 times 2, which is +2. This is my first term of this sequence. My second term, a sub 2, is going to be -1 to the 2 plus 1, 2 plus 1, and then times 2 to the second power. So that's going to be third power here, so that's going to be -1 times 4, 2 to the second power. So it's going to be -4. That's going to be my second term. And a sub 3, my third term, is going to be -1 to the 3 plus 1 times 2 to the third power. That's going to be 4. When we have a fourth power, that's going to be a +1 times 8, which is going to be 8 for our third term. And a sub 4 here, our fourth term, is going to be -1 to the 4 plus 1 power. That's the fifth power. And to the fourth here. So fifth power is going to be -1 here. So -1 times -1 times -1 times -1 is a -1. 2 to the fourth is 16. So we're going to get -16 for my fourth term. So the sequence itself is going to go 2, then -4, then 8, then -16, and it's going to continue on in that pattern. Alright, so that's how we evaluate the first 4 terms of a sequence. We plug in 1 through 4 into this sequence notation. Now the second part of this, or the third part of this actually, is finding that equation, and we're going to go try to find this equation from the pattern. Alright, so when doing that, what I really need to do is I like to look at how these are related to our n values. So our n values here are going to be 1, 2, 3, 4, and 5 for the term values. So our n values here, these are a sub n's. What we want to do is try to figure out how these are related this way. So how, if we put 1 in there, so my answer is going to be a sub n equals, we got to come up with a rule here. Whereas when I put 1 in for the rule, I get 3 out. When I put in 2 for the rule, I get 6 out. When I put 3 in for the rule, I get 9 out. Put 4, I get 12. 5, I get 15. It looks to me that the relationship here is that we're multiplying by 3, that it's 3 times the n value. And we can double check that. We can check that out and say, well, okay, what's a sub 4? That's going to be 3 times 4, which is 12. And then we would go up here to this term and see, oh, that is correct. We got, from the fourth term, we got 12. So that's a check to see if we have the correct formula. And we could check a couple of these in this formula to make sure that it's correct. But we want to relate the term number to the actual term. So there's a relationship there. We're not going to look at the relationship between these values. We can make some guesses. If we look at this, it's looking like my next term would be 18, and it does look like there's a difference of 3 here. So there might be a relationship there with this number and why there's a difference of 3. And we'll be looking at that in the next one of the next videos on some special sequences. When we deal with arithmetic and geometric sequences, there's some special patterns. Okay, my second example from this list is the values 2, 4, 8, 16, 32. Now let's look at the n values here on the top. Let's see if we can look at the pattern here. Alright, so we're looking at the pattern. 1 gives us 2, 2 gives us 4, 3 gives us 8, 4 gives us 16, 5 gives us 32. It's looking like it's growing. It's not. Looks like it's going up. It's getting bigger and bigger each time. This one over here was a multiple, but this one's getting bigger each time. This one we're multiplying by 2, then we're multiplying by 2. We're multiplying by a larger amount each time, it looks like. So this is a growing value, and this is, you should notice that this is increasing or doubling each time as well. So that's more like an exponential function. So we're going to think of this as an exponential function because it's doubling each time. So it's growing exponentially. That's the pattern we had earlier. So now if it looks like we're doubling, that's going to be 2 as our base. Exponentially 2 is our base, and then we have to figure out what the exponent is. In this case, I believe that the exponent is just n. Here we're relating it to this value, so I believe that that's the exponent. It could be some other exponent here, as long as we know that 2 to the third is, so we're going to check 2 to the third is 8, so that means the third term is 8, 2 to the fourth is 16, that's what we got on the fourth term, so these are seeming to check. We have the thing based upon it being an exponential function. It's growing each time more and more. It's not growing by the same amount. Here we were growing by 3 each time. Here we're growing by more and more each time. Now this one, my third and final example here of this type, we're going to be looking at the terms and how they're related. Okay, so this one we have a numerator and denominator, so we're going to split that up in our rule. A sub n, we're going to have a split rule here. It looks like the rule, the numerator is always going to be 1, so a sub n is going to be 1, it's continuing to be 1. Now we're going to look at how these are related. It looks like these are a constant difference here. It says here we're looking at these things as being, the denominators being 3 more than the n values, so that means it's going to be n plus 3. There's a relationship. 4 plus 3 is 7, 3 plus 3 is 6, 2 plus 3 is 5, 1 plus 3 is 4. So we're increasing, we're 3 more than our n value here. So I'm going to write my formula as 1 over n plus 3. And if we were to put 4 in there, we would get the right one. If we put 3 in there, we get 1 over 6. If we put 2 in there, we get 1 over 5. So it does check. So their relationship is this way, as well as looking at it in the other way. So those are some examples of how to write a sequence from, or how to write a rule from a sequence. So we're going to continue in the next video working more with sequences. That's what we're going to be looking for at the next video.